PowerPoint presentation. Now, please proceed. Thank you.
Thank you very much, Dr. Abdulhamid. Good afternoon, everybody. I'm Dr. Ahmed Jabas. I'm Assistant Professor at Sharia University, KSA. It's my pleasure to meet you. Today, we will discuss together some topics in data mining and mobile ad hoc networks. Hopefully, it will be interesting and useful. I would like to thank Dr. Abdulhamid, and shall we start?
Yeah, please proceed.
Okay. So, in this meeting, we'll discuss three main topics: association rules mining and mobile ad hoc networks, and we will merge association rules and ad hoc networks to get what's called MANET mining. So, the first topic is association rules. So, what's an association rule? Association rule is an interesting relationship or pattern that's hidden in the data. So, association rules mining finds interesting associations and relations in the large set of data. In other words, we can say what things go together. Let's take an example. If we go to search for a book in Amazon, you know that usually we buy some books from Amazon website. If you look for a book, say data mining. If you write data mining on Amazon website, you will get your book, isn't it? So here, for example, in this slide, I wrote data mining and I got the book which I'm searching for. If you scroll down, you will find this screen also. If you try it, it will give you, in addition to your research result, the following. It will give you suggested books. It will show you some suggested books. For example, here, let's say, data science, data mining, Python for data analysis, Python cache course. So all these books are related to data mining. So how Amazon within 2 or 3 seconds suggested you these books? This is what's called association rules. You will ask for one data book, for one data mining book, it will suggest you more books. This is what's called association rules. So keep in your mind that Amazon has a huge database, a huge data warehouse, maybe millions of books. So here we can't apply traditional programming. What the meaning of traditional programming? If you can't apply this condition in programming language. If somebody asks for this data mining book, display the following books. You can't apply that. Why? Because you have millions of books, okay? And maybe the time complexity, it's very huge. I mean, you need maybe 1 or 2 days to get the related books. But by applying data mining association rules, you will get the result within a few seconds. So, I asked for one book, I got related books. This is what's called association rules, okay? This is a small application, or what's called market basket. It's called the same scenario, it's called market basket. So for example, if you go to buy, for example, a bread, you will find the butter beside the bread. So the butter and the bread usually are bought by the customer. So we will keep them together. Same scenario here, okay? I'm looking for one data mining book. Suddenly I got several books, okay? And mostly you will buy these books. Sometimes you will find better books. I mean, you will look for one book, good book, you will find a better book with rating, for example, 5, okay? So this is what's called an association rule. Now, coming to define the association rule mathematically, I mean modeling of the association rules. So, say that we have history of Amazon, since we spoke about Amazon, say that we have a history of Amazon. For each transaction, we will keep in the figure here one tuple or one line, one row. So the first customer, he will buy some books and he won't buy some books, the remaining books, okay? So whenever the customer buy a book, we will keep one. If he doesn't buy the book, we will keep 0, okay? So we have a large number of books, I mean a large number of columns, L1, L2, L3, L4, LM. So these columns represent the books, book 1, book 2, book 3, whatever, the items, the books. And every line represents a tuple or a customer, a tuple or a customer. This is from the history. This is from the repository history of the database. So now to define the association rule, say that we have a database. In this database we have tuples, we have items or columns, okay? So the definition of the association rule is if left then right, or sometimes we read it X implies Y. It means if I buy a book or set of books X, I should buy also a set of books Y, okay? This is the definition of the association rule. Whenever you buy this data mining book, 99% or 95%, that depends, you will buy these books also. This is an association rule, okay? So, how can we discover the association rule? Usually we apply an algorithm for mining the association rule. The most famous algorithm is a priori algorithm, okay? As we said, I have millions of books. I can't say if then, if then, if then. So it's impossible. So what shall I do to get this result, to get these association rules? I should apply what's called a priori algorithm, okay? Of course, I have more algorithms to mine the association rules. For example, FP growth, ECLAT, and other algorithms. But we use the most famous one, a priori algorithm, okay? So, association rules mining has key measures, okay? Now we are modeling the association rules, we are defining, and now we will define also key measures. The most important key measures of association rules are support and confidence. The support and confidence. In our example, I mean in the database example here, we will define some counts. N left, of course, in the association rule, we have left hand side and we have right hand side. The left hand side implies the right hand side. So let's define some counts. N left, it means the number of tuples that contains the left hand side. N right, it means the number of tuples that has the right hand side. N both, the number of tuples or instances matching or including the left hand side and the right hand side. N total is the total number of tuples or instances. So, a Kramer notation proposed the following measures. Of course, there are more than one notation, but we adopted the Kramer notation, okay? For confidence, by definition, N both divided by N left. Okay, we have these counts, and now we are defining the measures. Confidence, it means N both divided by N left. Support, it means M both divided by N total. Completeness, M both divided by the right hand side. In fact, for the confidence, it's similar to the conditional probability. It means how likely it's for an event B to occur if an event A have already occurred. Okay? But here we are writing in statistical method. Okay? So now, after defining these measures, we will take small example, real example also. Look at this congressional voting records in USA. In 1948, they recorded the voting in a database. I mean, if we vote, or if the attribute is 1, we will keep a small bar. If it's 0, we will keep blank. So we got two figures here. For example, we have two figures. What's the difference between the two figures? In fact, we think that both they are meaningless. We think that both they are similar to each other. They are random. But the fact is they are not random. The first one is random, but the second is the voting data. So imagine that the first one is random. The second one is the real voting data. I mean, it's full of data. And after applying the association rules on this database, voting database, we got amazing association rules. For example, and with high confidence, we define the confidence measure, and here we got association rules with high confidence. Say, for example, you know that in USA, we have two main parties. We have Democrats, we have Republicans, okay? And we got those association rules in that database, voting records, voting database. Here, for example, in the first one, look, here we have these results, these association rules with confidence 91%, 97%, 93%, 100%. I mean, they are amazing association rules. Let's read the first one, for example. First association rule, budget resolution, no. What the meaning of that? If the members say no for budget resolution, and if the member says we need the missile, or we don't need the missile, no for missile, no for war, and yes to help El Salvador, then that member is Republican. So this is an association rule. Whenever the members say no for resolution, no for missile, I mean no for war, help El Salvador, then he will be Republican member, and with high confidence, 91 confidence. Okay? In the next one, if the member says, for example, yes for resolution, yes for war and missile, no for helping El Salvador, then the member will be Democrat, from Democrat Party. Same thing in the next association rule. Whenever the member says for crime, yes, for right to use, yes, physician fee freeze, yes, then he will be Republican, and so and so, okay? So imagine that the right-hand side figure is full of important data. But this data is hidden. This data is hidden. Do you understand anything from this figure? No. Even some people, they want to distinguish between the random on the right, on the left hand side figure, and the real one on the right hand figure. Okay, even though it looks random, but it's full of data, full of association rules, so that in the applications, I mean in the association rule applications, we may discover some crimes, we may discover some important relationships, I mean like Amazon. Okay, how Amazon recognize that you are fond of data mining books, simulation books, okay? Because you choose this book, 99%, for example, or 95%, you will buy also these books. So he will suggest you the exact books. And this happened several times with me. For example, I wanted to buy a small computer from Amazon. It's called Raspberry Pi, okay? And I kept this Raspberry Pi in the basket. I kept it in the basket. After a few seconds, it gave me good offer. He gave me, for example, the Raspberry Pi was $50, the price. Then he gave me Raspberry Pi plus some wires, plus cover, plus shipment for $60. Okay? He suggested me that. Immediately I canceled the Raspberry Pi and I kept that package. Second time, he gave me another offer. So this is the application of association rules in our real life. Okay? Great. We said that to discover the hidden patterns, I mean to discover the association rules, to mine the association rules, you have to apply a priori algorithm. We can't say if then. If I have millions of books, impossible to say if then. Okay? But how can we discover these association rules? Using a priori algorithm. Okay? Here the a priori algorithm, it's simple, it's not difficult, it's an iterative. Briefly, we can explain now, we can pass it, I mean, we'll explain it briefly. First, we have to generate the candidate. We have to generate the candidate item sets. And this, what's called C1 or candidate 1, C1, it means candidate item set of length 1. After that, what I'll do what's called pruning. Pruning, it means if these candidate item sets supported, for example, we say the support is 80%, 70%, 90%. We define the support, right? Earlier now in the measures, we define the support. So first step, it's an iterative algorithm. First step, I'll generate the candidate item set. Then I'll prune it using the support. Okay? And finally I'll get the maximum or I'll get the frequent set. I repeat, it's iterative. Generate the candidate item sets, prune, get the frequent set. Generate candidate, but first time I generate the candidate with one item. Then I generate the candidate with 2 items. Then with the 3 items, 4 items, 5 items. Okay? So generate for 1 item, prune. Generate for 2 items, prune. For 3 items, prune. Finally, you collect all the frequent sets and keep them in what's called L. So here, the last line number 14, it means the union of all item sets, and we will get what's called maximum frequent set. For example, if I have 5 columns or 5 items, so this is what's called maximum frequent set. So briefly, it's an iterative algorithm, and it will start by the candidate item set, then pruning to get the item sets. Okay, we have 4 from line number 9 and line number 10, 11, 12. It's iterative algorithm. Okay. Anyhow, to see the result of this algorithm, you can use Weka application. It's a free open source application. Okay. You can pass this algorithm on Weka. Okay. So now we completed some topics in data mining. We focused on association rules mining, and now we will come to the ad hoc network. Okay, as we said in the first slide in the outline, we have data mining, we have mobile ad hoc network, then we apply data mining in ad hoc network. So now coming to the second topic, main topic, what's ad hoc network? What's an mobile ad hoc network? Mobile ad hoc network is a collection of autonomous nodes or terminals that communicate with each other by forming multi-hop, decentralized, self-configured, self-healing radio network. So briefly, say that we are a set of students, and every student, he has his own laptop. Okay, we can switch the Wi-Fi of our laptops, for example. So this is what's called ad hoc network. So from the figure, we can say that the node A will communicate with node B, but node B, it is out of the range of node A. So node A will send to the neighbor, and the neighbor will send the neighbor. Finally the packets will reach to the destination. This is briefly what's called ad hoc network. Of course, whenever we say MANET or mobile ad hoc network, we have zero infrastructure, no infrastructure at all. The ease of nodes deployment comes on the cost of stack protocol, including MAC, routing, security. I mean, it's very simple to switch on your Wi-Fi and communicate with your friends, okay? But it's very difficult to manage the security. It's very difficult to manage the routing. It's very difficult to manage the battery problems, okay? And the transmission problems, okay? So till now, we are simulating the ad hoc network. Till now, it's not applied. Of course, we have, let's say, some small applications like vehicle mobile ad hoc networks. We have, okay? But we have a lot of problem in security, and till now is not solved completely. We have a lot of battery problem, for example, power problem. You will switch on, finally, your battery will be off. So how will you manage after 5 minutes, 10 minutes, 1 hour, okay? Because all the nodes are involved in routing, okay? This is not our focus today. Just we had small idea. We have some changes, some challenges in MANET, like the limited wireless transmission range, the nature of the wireless medium, such as we have first problem, it's called hidden terminal problem, exposed terminal problem. We lost a lot of packets, usually. We have a change in the topology because we say mobile ad hoc network. What's the difference between the Wi-Fi, normal Wi-Fi network and the mobile ad hoc network? In mobile ad hoc network, we are moving, say that we have students they are moving inside the department, say that we have in the war tanks, we have airplanes, we have, okay? So, mobile ad hoc network, it means changing topology, okay? Of course, we have battery constraints, and we have a lot of problems in security. Why? Because in normal networks, we depend on third trusted party. I don't trust you, you don't trust me, I don't know you, you don't know me, but we know Dr. Abdul Hamid. I trust him, you trust him also, isn't it? So I trust you, you trust me. But in mobile ad hoc network, if the nodes depend on a single or on a third trusted party, and this third trusted party gone, Say that this airplane gone, this student left the department. So what will happen? The whole network, mobile ad hoc network, will collapse. The whole mobile ad hoc network will collapse. Of course, we won't go in depth in the mobile ad hoc network. Just we will focus a little bit on the security. We said in the security there is no third trusted party. I don't trust you, you don't trust me. This is very big problem. How I'll communicate with you? Okay? I suggested some solution via applying a priori algorithm to the traffic of mobile ad hoc network, as we will see later. Okay? So now we explained association rules mining, MANET, mobile ad hoc networks, and now we will come to the third topic, how we will apply association rules in mobile ad hoc network. I found some visions of convergence between association rules mining and mobile ad hoc networks. First, as we explained, each transaction or each tuple in the data mining is a set of items or attributes. If we go back to the table, we will find that we have set of attributes, I mean columns, items, books, okay, and we have a set of tuples. Here in MANET, instead of the books, keep notes, we have a set of notes, and each customer or each packet is similar to the customer. The customer, he will buy the first book, the second book, third book, okay? Here for the packet, he will pass from the notes. Then briefly we can say the columns are the nodes. The columns are node 1, node 2, node 3, okay? And the tuples are packet 1, packet 2, packet 3. If the packet passes via the node, we will keep 1. Otherwise, we will keep 0, okay? The second point, data mining is applicable to a database with a large number of transactions. Usually, data mining is not applicable for 2 tuples or 3 tuples. We have millions. Look at Amazon. How many customers we have? Millions of orders and customers. Okay? Same scenario here. We don't have here 1 or 2 packets or million or 2 million. We have millions or maybe billions of packets. Okay? This is the second point. The third point, the purpose of mining association rules in a database is to discover all rules with support and confidence. These rules are important for us to buy books, to know the political orientation, as we saw, whatever, okay? In case of MANET, the rules represent the most likely patterns among packets and the cooperated nodes. As we saw in the mobile ad hoc network, we have source node and destination node, and the packets are passing from hop to hop, I mean from node to node to node. Finally, it will reach the destination, okay? So, we have cooperated nodes, okay? Routing nodes. The fourth point is each frequent set in the data mining needs different packets with common nodes, okay? So, we have a frequent set in the database and we have common nodes in the MANET. There it's called frequent set. Here we can say common nodes, okay? So these are the main points, main visions of convergence between MANET and between data mining, namely association rules, and mobile ad hoc networks. Let's take an example, demonstration. Let's explain this demonstration. Demonstration on a simple MANET. We said that the MANET is a set of mobile nodes. Okay? So the nodes or the topology is changing. The nodes are moving. Take this simple scenario. We have in the first figure, we have 15 nodes, and we have node number 1 is the source. Node number 2 is the destination. So we have some packets passed from the first path. The first path is 1, 3, 5, 6, 9, 14, 13, then the destination 2. The topology little bit changed. I mean the nodes moved little bit. So the new path 1, 3, 4, look in the first figure, figure number 1, the packets are passing from 1, 3, 5. But in the second one, look at the arrows, 1, 3, 4, 6, 9, 14, 13, 2. It's different path. Again, the topology within few seconds changed, and the packets now are moving from node number 1, I mean from the source to the destination, node number 2, via the path 1, 3, 4, 6, 15, 14, 8, so on and so. Again, in the fourth figure, we have a new path from the source to the destination. So we have a few packets passed from the first path, few packets passed from the second path, we have a few packets passed from the third, and so on. So this is the database, or the Boolean database, or the matrix, call it whatever, which we obtained from this demonstration. Here I have 1, 2, 3 packets. Then I have 3 packets, I mean the first 3 tuples. Then I have 4 tuples in different color. Then I have 3 tuples. Then I have 5 tuples. Okay? So this is the corresponding database for this demonstration. Now apply a priori algorithm, you will get frequent sets. And here, just to make it simple, we took only the maximum frequent set. The maximum frequent set, N1, N2, N3, N4, N6, N14. This is the maximum frequent set. So this maximum frequent set may be used as a common token between the source and the destination. The source is node 1, the destination is node 2. Okay? What the meaning of common token? Common token, it may be a password. I mean, why? How can the source and the destination communicate with each other? We have 2 ways. Either by a common token, I mean using password, or using key pairs. You know that in encryption, we have 2 ways for communication, either by using key pairs, and here it's a little bit difficult, and we have common token, I mean password. So this maximum frequency set, it might be used as a password. So some student or somebody will ask, sir, it's not secret, but I'm telling you it's secret. Who can calculate this maximum frequency set? Only the source and the destination. Say that another node in middle, this is what's called in security world, man in middle. Say that there is man in middle, and he is collecting the path from the source to the destination. He will collect maybe 50%, 60%, 70%, I don't know what the percentage. And the algorithm is very clear, it's a priori algorithm. He will apply a priori algorithm, but he will get different result. And this is simulated. I simulated it, and I proved it mathematically, and experimentally. Here, I don't want to go in depth in this regard. If anybody is interested, I can send him the paper or the details of the papers, okay? So, this maximum frequency set, it will be, briefly, it will be obtained by the source and the destination only. So, it's common. Of course, man in middle, if he applies some brutal methods, he may get it. He may get this maximum frequency set, but it will take maybe from him hours or maybe days, okay? It will take days from him, or at least hours, in the worst case. But for me, I calculated it within 2 or 3 seconds only. So I can change it every 2-3 seconds, every 1 minute, every 2 minutes, okay? So any password is breakable. Any password is breakable. But why the policy of changing password force you to change your password every 6 months? Sometimes, some policies, they will tell you your password will expire within 3 months, within 6 months, and you must change it. Why? Otherwise, your account will be locked. Because maybe somebody is trying to break your password. He is trying all the possibilities. Brutal force, okay? So, here, now we can summarize that I applied a prior algorithm, I got maximum frequency set. I got not only maximum frequency, I got all frequency sets. But this is the maximum, the longest. How many items here? In 1, 2, 3, 4, 5. We have 6 items, so it's called L6. Okay. This is the demonstration and applying the prior algorithm on this demonstration. I defined, this is my definition, I defined a correlation ratio. The correlation ratio is to divide the number of nodes in the maximum frequency set divided by the total number of nodes involved. For example here, I got in the maximum frequency set 6 items. I divided it by 12. Why? Because I have 12 nodes. So this is the ratio. I defined this ratio for my own work. Coming now to the simulation. In the simulation, I used the simulator NS2, the open source simulator NS2 from Berkeley University. Of course, we have different types of traffic in mobile ad hoc network. Not in mobile ad hoc network, in general, in all networks. So, first type of traffic, we have connectionless. The second is connection-oriented. Connectionless, or it's called UDP, User Datagram Protocol. Or connection-oriented, it's called Transmission Control Protocol. What the difference between them? In the first one, UDP, you will send the packets and no need to receive the acknowledgements. In the second one, you will send the packets, you will receive the acknowledgement. So for us, we can mine the data packets, we can mine the acknowledgement, we can mine both the data packets plus the acknowledgement packets, okay? In the simulation, of course, we have specific protocols for mobile ad hoc networks. We have 2 main categories, proactive and reactive. Proactive, it means to calculate the route or to calculate the routes in advance. In the second type, reactive, to calculate the routes on demand. We won't go in depth. First one, it's called DSDV, Destination Sequence Distance Vector. The second one, it's called Ad Hoc On Demand Distance Vector, I mean for the reactive. The second reactive protocol, it's called DSR, or Dynamic Source Routing. So, for us, doesn't matter. We can apply mining on the traffic regardless of the routing protocol. Okay? These are the parameters used in the simulation. We have 100 nodes. We have routing protocols, as we explained, reactive, proactive. We have mobility model. We said that we are simulating mobile ad hoc network. It means the nodes are moving. How the nodes are moving? I mean, in which pattern? How they are moving randomly, or they are following specific function, whatever. Here we choose random way of the nodes. Post time, we choose 1. So the nodes, they may move and stop, move and stop, okay? Radio transmission range, we said, whenever we say mobile ad hoc network, it means we are using wireless communication. Wireless, it means range. So what's the range? Here we choose 250 meters. And the capacity of the channel. So how many megabytes or megabit I'm sending in the second? Here we choose 1 megabit per second. Data flow. Data flow, it means the application. We have different types of applications. We have applications with constant bit rate. Constant bit rate, it means like broadcasting. Whenever you are watching TV, on the net, this is constant bit rate. But whenever you're downloading a file, this is FTP, file transfer protocol. We have different parameters, including the packet size. We choose 512 bytes. Node placement at the beginning. Where shall I keep the nodes? Randomly, we choose. And we have the area for the simulation. We choose 1500 meters by 1500 meters. And we have different routing protocols, as we explained. AODV, DSDV, DSR, okay? And we have propagation model. It means how the signal will be sent. We have wireless signal. We choose 2-ray ground, and we have speed. The nodes are moving. So since the nodes are moving, the nodes may move fast, or maybe we may slow them. So we choose the speed 5 meter per second, 10 meters. Usually, we in the simulation we use 5, 10, 15, 20. Okay. And we got this parametric study. Here, of course, I have a lot of parameters. I can't study all of them. Okay? But here, in this parametric study, we have delta. What the meaning of delta? Delta, it means I'm applying association rules mining. Whenever I say delta equal to 2 seconds, it means every 2 seconds I'm applying the algorithm. Whenever I say delta equal to 3 seconds, it means every 3 seconds I'm applying the a priori algorithm. Whenever I say delta equal to 4 seconds, it means I'm applying a priori algorithm every 4 seconds. S is 60%. It means the support. It means the support is 60%. As we defined, as we explained, we defined different measures, including support. Okay. And here the ratio which I defined. So the relationship is between the speed and the ratio. The speed and the ratio. So it means even though the nodes are moving, the ratio and the relationship, the patterns are available. So here we can speak abstractly. Even though the nodes are moving, but still there are relationships between them. Still, association rule available between these moving nodes. Here we have different parameters. I kept some slides only for the parametric study because we have a lot of parameters. And coming to the end, these are the references. Thank you for listening. Feel free for any question. So, any question, Doctor?
Dr. Jabas, I have a couple of questions. Very first thing is, why did you opt a priori algorithm for your MANETs? And second clarification what I felt of asking is like, why did you use particularly NS2 simulator? And the final question is, the application what you have done for your 100 nodes data, can this be applied on real-time very large MANET? These are the three questions I thought of asking you. Please,
I see.
Please clarify.
So we'll start one by one. Do you mind? Because I forgot them. Okay. Let's start by the first one, please.
First one is, why did you opt a priori algorithm particularly?
Why did I choose a priori algorithm? Okay.
Yeah.
Look, it's not compulsory to use a priori algorithm. We have, for example, FB growth, ECLAT, and frankly, they are faster than a priori algorithm. But a priori algorithm, we can consider it as a metric or de facto algorithm. It's the first algorithm proposed by Agrawal, okay? So now, even if we apply another algorithm, for example, ECLAT or FP growth, we will say this is faster than, twice faster than a priori, a triple faster than, okay? So we can say, we can apply different algorithms. If you use, for example, Weka, you can apply another algorithm, you will get the same result, the same frequent set, the same maximum frequent set, but a priori algorithm is, consider it as a de facto algorithm, consider it as metric algorithm, just to refer to it. But you are free, you can apply any other algorithm on Weka, for example. You will get the same result. Doesn't matter. This is the first question.
Yeah.
The second question.
The question was like, why did you opt NS2 simulator particularly?
I see. Okay. We have more than one simulator. We have, for example, GlomoSim, we have NetSim, we have OpNet. But the beauty of NS2 is, one, it's a free, open source. Two, it's fast. Comparing to other simulators, it's really fast. Okay. What the meaning of open source? Open source, it means you can open the protocol, modify on the protocol, and don't pay money at all. Okay? Of course, somebody will ask, okay, since it's free, why people they are buy other simulators? Because, frankly, NS2 is more difficult comparing to other simulators. Okay? It's free. It's fast. But it's difficult at the same time. Okay? And almost 50% of Mobile Ad Hoc Network simulations are performed using NS2. Right? So this is the beauty of NS2. Next question, please.
The last question is like, you have taken the data set of almost 100 nodes. My point is, can this work be applied on real-time data set which is holding huge data in real-time MANETs?
Okay. For association rules, yes, it works in the real time. Above all routing algorithms in MANET, as we said, we have two categories of routing algorithms in MANET, and it will work for sure. But where is the problem? The problem in the simulation. So I can simulate a MANET with 100 nodes, 100, 200, 300, 400, but I can't simulate a MANET even in NS2. We said that NS2 is the fastest, okay? Is the, let's say, number one in simulation and it will give you the result before, or it's the fastest among all simulators. But if you say that I have a MANET with 2000 nodes, frankly, I can't simulate. Even NS2 can simulate. Why? Because it may take, I don't know, maybe 1 year, 2 years to simulate, and the output will be huge. Whenever I simulate a network with 200 or 300 or maximum 400 nodes, the output will be in giga. So imagine for small networks, for small number of nodes, say 200 or 300, the output of the simulation will be, for example, 2 giga or 3 giga. But whenever you have 2000 or 3000, you may need 1 year to simulate. And the output, it will be in tera, maybe. I mean huge output. So, association rule designed for a huge databases. But the simulation for this huge MANET is difficult. So, till now, I didn't find anybody simulated more than 400 or 500 nodes maximum. Otherwise, it's applicable. And what's the proof? The proof is, look at Amazon. You have millions of books. You have billions of transactions, but it will suggest you. I mean, within a few seconds, it will give you the result. Right? Any other question?
I think these questions are sufficient. I really thank you for your for coming to Research 101 platform. The presentation was very informative and literally making the whole concept very clear and explaining all the insights provided in your work. This will definitely help not only research scholars, but at the same time, in future, if any master's student or any undergraduate, if they want to perform their project work, I think the inputs what you have provided are so clear and so complete that they can really perform reverse engineering by putting your paper in front of them. That will definitely help them. And this interview of yours on Research 101 will definitely be a torch. It's like a torch bearing to future generation and to perform their work, and also a great support for the research scholars, the young research scholars or the budding research scholars who want to understand the way the two different domains are mixed to come out with a new concept. The way you have combined the a priori algorithm with MANETs, and how the hidden patterns are derived, extracted, are really good and very interesting. I thank you for your time. I thank you for your effort, and I thank once again. Thank you.
Thank you very much, Doctor, for this nice invitation. Thank you for the listeners. I'm ready for any help and wish them all the best. Thank you.
Welcome.
Thank you.
Bye-bye.
Bye-bye.